Welcome to the debate. Just right off the bat, before we dive into things, we need to mention that the video for this show is completely self-produced.
Yeah, entirely in-house.
Right. But more importantly, today's specific debate topic is an idea for hut.
It really is a fascinating one, too.
It is. We are taking a really close look at this wildly popular science fiction concept, the Sophon. It's from that huge sci-fi story, The Three-Body Problem, and we are comparing it to the real world of quantum computing.
Because there is a lot of overlap, but also a lot of fiction.
Exactly. So our core question today is this. Does science fiction like this actually help us understand complex quantum physics? Or, and this is where it gets tricky, does it create dangerous misunderstandings that fuel, harmful stock market bubbles?
Right, the real-world money side of it.
Yeah. Now, I will be arguing that science fiction is this really powerful educational bridge. I think it helps everyday people grasp nearly impossible ideas like superposition and qubits.
And, well, I will be arguing the opposite. I believe that when science fiction blurs the line between real science and, honestly, pure magic, it actively misleads the public.
You think it does more harm than good?
I do. That public misunderstanding leads directly to dangerous financial bubbles. Bubbles that are driven by tech billionaires and just pure market hype.
Well, let me start by laying out my perspective here. The story of the Sophon, it introduces millions of people to real physics.
Okay, but how?
Well, imagine you could take a single microscopic proton, right? One of the tiny building blocks of the universe. In the story, the aliens unfolded, almost like a piece of paper, opening it up into 2 dimensions until it is large enough to wrap around an entire planet.
Which is a stunning image.
It is. And then they use a massive laser to draw complex computer circuits all over its surface. Finally, they fold it all back up into a tiny invisible speck. They essentially build a supercomputer the size of a proton.
Right, and they call it a Sophon. It feels like pure magic.
It does feel like magic. And look, of course, this is fiction. We cannot actually build a computer inside a single proton. But the author uses this wild idea to introduce very real, very complicated concepts to the general public.
Concepts like entanglement.
Exactly. Because of this story, ordinary people are suddenly talking about quantum entanglement. They are thinking about how quantum computers might one day break modern passwords and encryption. I mean, science fiction takes incredibly dry, difficult math and turns it into an adventure.
I hear you. And I agree that the story is exciting. It really is.
It gives people a reason to care.
It does. But we have to look at the cost of that excitement. I argue that it actively tricks people into misunderstanding how physics actually works.
Tricks them how, though?
Well, for example, in the novel, the aliens use quantum entanglement to communicate instantly across light years of space. They use this magic zero-delay communication to spy on humans and basically stall our scientific progress for 400 years.
Right. They block our particle accelerators. It makes for a great villain.
A great villain, sure. But in a real world, there is a strict, unbreakable rule in physics. It's called the no communication theorem.
Ah, the no communication theorem.
Yeah. This theorem proves that quantum entanglement absolutely cannot send information or signals, like none, zero. By ignoring this massive rule, the story tricks the public into thinking quantum technology is just magic.
I think tricks is a strong word, but go on.
Well, when people think a new technology is magic, they throw their money at it blindly. And this leads to wild, dangerous swings in the stock market based on nothing but hype.
Okay, I see why you think that. But let's look a little closer at how the story actually explains entanglement, because it's not all fake.
Okay.
So the aliens are 4 light years away from Earth. They fire these Sophons, the proton computers at our planet. The Sophons travel at near light speed, so they take several years to cross the dark, empty gap of space.
Right. They don't teleport. They have to travel physically.
Exactly. But here is the trick. Once the Sophons arrive on Earth, they stay deeply connected to their twin protons back on the alien homeworld. Whatever happens to the proton on Earth instantly happens to the proton 4 light years away.
Which is where it gets tricky.
Sure, but Albert Einstein actually struggled with this exact idea in real life. He mocked quantum entanglement. He famously called it spooky action at a distance, because it seemed to break the speed limit of light. I think the book gives the reader a very clear mental picture of how two particles can be linked across vast distances.
Right. But that mental picture, that is exactly the problem. The book teaches the reader that linked across space means you can send messages across space, and that is scientifically false.
But entanglement itself is a completely real phenomenon. It is a literal cornerstone of quantum mechanics today.
Oh, yes, entanglement is absolutely real. I'm not denying that. If two particles are entangled and you measure the one here on Earth, its partner's state is instantly set, no matter how far away it is in the universe.
Right. Instantly.
But here is the critical difference, and this is the reason why we have the no communication theorem. You cannot control what your measurement will be.
Okay, break that down for us.
Let's use a simple example. Imagine we have a pair of magic dice. We entangle them, I keep one on Earth, and I send you to Mars with the other one.
Okay, I'm on Mars with the magic die.
That is the spooky action. But here is the catch. I cannot make my die land on a 6. The roll is still completely random.
So because you can't control it, you can't use it as a code.
Exactly. Because I cannot control the outcome, I cannot use the dice to send you a secret code or a text message. If I want to send Morse code, I need to be able to choose the signals. I need to choose dots and dashes.
Right, that makes sense.
But the Sophon story tells people you can use those magic dice to send the text message. So aren't we causing harm when we teach millions of people that quantum physics is just a magic telephone?
Well, and that is a great explanation of the magic dice, by the way, but I still do not think the story is harmful. I see it as a gateway.
A gateway to misunderstanding.
No, a gateway to learning. Before someone can understand the complex math of why you cannot send a message, they first need to know that entanglement even exists at all. The Sophon provides the wow factor. It gets them in the door.
I guess, but
Let me just say, once they are curious, they can read an article or listen to a show like ours and learn the actual rules. Look, science fiction has always bent the truth to make a good story.
bending the truth has consequences.
Does it always, though? We do not get angry at movies for showing spaceships making loud swooshing sounds in the vacuum of space, even though there is no sound in space. We understand it is just for entertainment. We should not get angry at a story for tweaking quantum mechanics to make a scary villain.
I have to push back there. A swooshing spaceship in a movie does not cause people to lose their life savings in the stock market.
Oh, come on.
It's true. Quantum computing hype does. When you teach people that quantum technology is a magic wand that ignores the laws of physics, you set them up to be exploited by marketing and bad investments.
Okay, well, let's transition to that real-world technology then. Because while the instant communication might be fiction, the book introduces another massive concept that is completely real, and that is the qubit.
Right. Qubits are the foundation of real quantum computers.
Exactly. The general public understands that normal computers use bits, right? Zeros and ones. But quantum computers use qubits. Because of a real scientific property called superposition, a qubit is not forced to be just one thing at a time. It behaves more like a wave.
Being a 0 and a 1 at the same time.
Yes. And when you combine the wave nature of superposition with entanglement, quantum computers can process certain types of massive problems much, much faster than regular computers.
They can, yes. And I think it is really important we explain exactly how they do that, so it does not just sound like more magic to the audience.
That's fair, exactly. So think of a regular computer trying to solve a complex maze. It has to walk down every single path, one by one.
Very slow.
Very slow. If it hits a dead end, it turns around, goes back, and tries the next path. It takes a very long time. A quantum computer, using superposition, is more like flooding the maze with water.
I like that analogy.
Thanks.
The water explores every single path at the exact same time. Through a process called quantum interference, the waves of water that hit dead ends crash into each other and cancel out. The waves that find the correct exit build up and become stronger.
So it just washes right through to the solution.
Exactly. This allows the computer to find the right answer incredibly fast. This is why the aliens in the book are so afraid of human science.
And in the real world, this is the exact mechanism that threatens our daily encryption.
Right. Every time you buy something online or log into your bank, your information is protected by math problems. These are problems that would take a regular computer thousands of years to solve.
But a quantum computer could flood the maze.
Yes, flooding the maze, it could, theoretically, find the answer and crack those passwords in a few hours. That is not science fiction. That is a hard, mathematical fact. Governments are already spending money to figure out new, quantum-safe passwords. The book simply helps everyday people visualize a very real threat.
Okay, I agree completely with the science you just explained. The math behind the maze is real. The threat to our current passwords is a real possibility. But this story creates a narrative that the threat is arriving tomorrow.
You think it's exaggerating the timeline?
Absolutely. It strips away all the massive, real-world engineering challenges.
What do you mean by stripping away the challenges?
Well, keeping a qubit in that delicate wave state, the water in the maze, is incredibly difficult. It is called quantum decoherence.
Right, decoherence.
Yeah. Any tiny bit of heat, or even a stray magnetic field from across the room, will cause the qubit to collapse. The water in the maze instantly dries up.
Because it's so sensitive?
Exactly.
To keep qubits stable, we have to build giant cooling systems that drop the temperature to near absolute zero, which, by the way, is colder than deep space.
It is extremely cold.
So building a quantum computer is like trying to build a massive skyscraper out of wet sand while an earthquake is happening.
Okay, that sounds stressful.
It is. The math says a skyscraper is possible, but the engineering is a nightmare. Science fiction skips the earthquake and the wet sand. It just shows the public a finished, shining skyscraper.
But showing the public the finished skyscraper is exactly what gets people to care in the first place. Caring is fine. Panicking is not. Because the public thinks the skyscraper's already finished, they panic about their bank passwords being stolen tomorrow.
I mean, they should be a little concerned.
Concerned, yes, but they do not focus on how the machines actually work or how fragile they are. They just focus on the fear and the fantasy. And this connects directly to the real-world money.
You are talking about the billions of dollars being invested by companies like Google, IBM, and NVIDIA?
Yes, I am. These massive companies are pouring money into quantum tech, and the stock market goes completely crazy over it. But because everyday investors do not understand the wet sands problem, they trade based on pure emotion.
Well, the stock market is always a bit emotional.
Sure, but here they trade based on the magic they read in science fiction. Let's look at a real example involving NVIDIA's CEO, Jensen Huang.
Okay, Jensen Huang.
About the future of computing, the market is naturally going to listen to him.
Listen, yes, but look at the extreme volatility. In January of 2025, Jensen Huang expressed some mild doubts about how fast quantum computing would actually be useful. He essentially pointed out the wet sand problem.
And what happened?
Quantum computing stocks, like IonQ and Rigetti, absolutely crashed. People panicked and sold everything. Then, just a few months later, in June of 2025, he made a more optimistic statement about using quantum machines for artificial intelligence.
And they went back up?
Boom. Those exact same stocks went soaring again. I argue this massive, dangerous volatility happens exactly because people believe the sci-fi hype.
Wait, how does science fiction cause that volatility, though?
Because the investors do not have solid ground to stand on. If you invest in a normal car company, you can look at how many cars they sold. You can measure it.
Right, concrete numbers.
But when you invest in quantum computing based on the fantasy of the Sophon, you are investing in a dream. So when a famous CEO says one negative word, your whole belief system collapses and you sell. When he says a positive word, you buy back in.
It's reactive.
Extremely. If the public actually understood the slow, difficult, freezing cold reality of quantum physics, the market would be much more stable. We would not see these wild crashes.
Okay, I hear what you were saying about the market swinging wildly, and, well, it is true that people react emotionally, but I will defend the visionaries here.
Go ahead.
Just because the stock market is sensitive to leaders like Jensen Huang, that does not mean the science fiction is bad. In fact, I believe science fiction gives these companies the bold vision they need to secure those billions of dollars in the first place.
You mentioned that building these computers is like building a skyscraper out of wet sand during an earthquake.
It is one of the hardest engineering tasks humans have ever tried.
Exactly. It is insanely difficult. So to keep going, to keep paying for those massive cooling systems, you need a grand, exciting goal. You need a dream.
But a realistic dream.
Without the dream of building something as world-changing as a Sophon, we would not have the drive to push the boundaries of reality. Investors will not give you billions of dollars to just play with cold, wet sand. They give you billions of dollars because you promise them a skyscraper.
Even if the skyscraper is a long way off. Right. Jensen Huang moves the market because people trust his vision of the future. Science fiction writers write the first draft of that future. They paint a picture so beautiful and so terrifying that we feel we have no choice but to try and build it.
But the volatility...
Yes, the market will go up and down. People will buy and sell based on hype. That is how innovation works. It is messy, but the end result will be real technology that changes the human race.
I just wish that first draft of the future came with a clearer warning label.
A warning label?
Yes. A label that says, actual physics does not work this way. When companies see their stock prices double or get cut in half in a single month because of a single quote, real people get hurt. Regular people's jobs and retirement funds are on the line.
That is a fair point.
I want us to build quantum computers. I think the technology is incredible, but I want us to build them based on the real magic of the universe, not a misunderstood cheat code from a novel. The truth of superposition, the idea of exploring a maze with water waves, is fascinating enough. We don't need to pretend we have magic dice that can talk faster than light just to make science interesting.
That is a completely fair perspective. It is entirely true that the gap between a sci-fi novel and a working quantum computer is massive.
Very massive.
And the journey across that gap is full of really hard math, fragile hardware, and, as you pointed out, serious financial risk. But I still maintain that stories like the Sophon do more good than harm.
We'll have to agree to disagree on that.
That's fine. They take the invisible world of quantum mechanics, a world that is too small for our eyes to see, and they make it visible. They give everyday people a vocabulary to talk about things that are incredibly strange and hard to understand.
The challenge for all of us, then, is making sure that vocabulary does not become a tool to trick people. As long as we take the time to explain the real rules, like we did today with the magic dice and the no communication theorem, we can enjoy the fiction without getting burned by the reality.
That is a perfect point to start wrapping up our discussion. As we always do, we are going to provide a clear summary, a konjungyoyak, of both sides for everyone listening. We want to make sure these massive concepts are easy to take away.
Sounds good.
To summarize my argument, I believe that science fiction stories about things like proton supercomputers are amazing educational tools. They take impossible math and turn it into exciting stories. These stories teach everyday people about real concepts like qubits, superposition, and how future computers might break our current passwords. And most importantly, these stories give visionaries the inspiration they need to raise billions of dollars and actually build the future.
And to summarize my side of the debate, we have to be very careful. When we mix real physics with pure fiction, like ignoring the fact that quantum entanglement cannot actually send a message, we create false hope and false fear. This magical thinking makes the public misunderstand the technology, and that misunderstanding leads directly to crazy, dangerous stock market bubbles where companies gain or lose billions of dollars just because a CEO changes his tone of voice.
As always on this show, we will not declare a winner today. We leave it entirely up to you, the listener, to decide where you stand. Quantum mechanics will always be a little bit mind-blowing.
That is an understatement.
It really is. It completely challenges everything we think we know about reality, from how information moves to how objects exist in multiple states at once. You have to decide if you prefer the beautiful, limitless dream of science fiction or the strict, grounded rules of real physics.
The universe is strange enough on its own. We just have to keep trying to understand it clearly, one quantum bit at a time.
Well said. Before we go, we want to remind our audience one last time that today's debate was a design by Hut Hote, and their idea made this deep dive possible. Thank you for joining us as we unfolded these massive concepts. Until next time, keep questioning the universe around you.